This is a review from section 1 and 2. Find the 6 trig functions. You need to find this side. You can use Pythagorean theorem. So that would be 7 squared plus x squared equals 25 squared. When we solve for x, we'd have x squared equals 576. So x would be 24. So that would be this side, is 24. And then we can state the 6 trig ratio, sine, cosine, tangent of, we'll do angle A. So sine of angle A would be 7 over 25. Cosine of A would be 24 over 25. Tangent of A would be 7 over 24. And then we can do the 3 reciprocal functions. And you need to know the names, the abbreviations of those. So sine corresponds to cosecant, CSC. Cosecant is spelled like this. Cosecant. Cosecant A is 25 over 7. The reciprocal of cosine is secant A, which is 25 over 24. And the reciprocal of tangent is cotangent, COT, which is 24 over 7. So those are the 6 trig functions. Write an equation with sine, cosine, or tangent that can be used to solve. So on this one we have an angle 53, and we're looking for the opposite of that angle. And this side across from 90 is the hypotenuse. So we would use sine. Sine has opposite and hypotenuse. So that would be sine of 53 degrees equals x over 17. And when we multiply both sides by 17, it's 17 sine of 53. So that would be 13.6 units. The next one, 25 degrees, we're given opposite of that angle, and this side is adjacent to that, so we're looking for the adjacent. So that would be tangent 25 degrees equals opposite over adjacent, which is x. To solve for x, basically you're going to switch the x in the tangent 25's position. So you would have x tangent 25 equals 9. So x is 9 over tangent 25. And when you do that in your calculator, that would be 9 divided by tangent 25, which is 19.3 units. To solve a triangle, notice the directions, solve triangle ABC. To solve a triangle means find everything, every angle, 3 angles and 3 sides. You'll be given half of those. So you could draw right triangle. Angle C is the right angle. It doesn't matter where you put A and B. I'll put A at the bottom and B at the top. Little a, lowercase a, is across from uppercase A. And then lowercase b is across from angle B. And we need to find this side, segment AB. So that's Pythagorean theorem, 15 squared plus 20 squared equals AB squared. And when you solve that, you would get the square root of 625. So AB is 25. Then you can solve for an angle using trig ratios. Solving for angle, I usually pick angle A before B just because of alphabetical order. It doesn't matter which angle you pick. If I solve for angle A, I can use sine, cosine, or tangent, any of the 3 trig ratios, because I know everything about the sides. So I'll do sine of A equals 20 over 25. And then to solve for A, when you have sine A, to solve for A you have to do the inverse of sine. 20 over 25. So that would be the inverse of sine, 20 over 25. And when you write your answer, don't forget to include degrees, 53.1 degrees. And then lastly, to solve for angle B, you could do another trig ratio, sine, cosine, or tangent, but it's much easier to know that A and B are complementary angles. So the sum is 90 when you add them, so 90 minus the angle we just got would be 36.9 degrees. So now this triangle is solved. We know everything about that triangle, the lengths of the sides and the angle measures. The next one says an airplane climbs at an angle of 11 degrees with the ground. Find the ground distances traveled when it's attained an altitude of 10,000 feet. So you have the ground right here. Airplane is flying at 11 degrees. Here's my fancy airplane. The altitude is 10,000 feet. Altitude is how high off of the ground it is altitude. Altitude. 11 degrees. With the ground, that would be this angle in here is 11 degrees. And the altitude is perpendicular. So we're looking for the ground distance, x. So we could do tangent of 11 degrees is 10,000 divided by x. We saw one earlier like this. You could switch the x and the tangent. Tangent 11. And if I remember correctly, the answer is 51,445.5 feet is the units. But you can get that on your calculator. I think that's the right answer. That's all from section 1. Section 2, drawing angles, is pretty easy. 200 degrees is between 180 and 270. There's 90 up here. So you would graph an angle that looks like this, and make sure you include your rotation. So I can tell it's a positive angle measure, which is counterclockwise. 450 degrees, you're going to go around the circle once, 360. So if you subtract 360 from that, you're going to end at 90 degrees. So your angle would look like this. You go around once, and then a little bit more than that. A quarter of a circle. So that would be 90 degrees, which 450 is what it would be. Negative 115, you're starting at 0 still. Down here is negative 90 going clockwise. So 115 would be this angle, somewhere around there. And make sure you show your rotation. And then negative 270 would be this angle, counterclockwise. So that's drawing angles, and we'll do more of that on the next page. Converting from radians to degrees or vice versa. This is degrees. You can see the degree mark. So whenever you multiply, you want your 180 degrees in the denominator, so the degrees will cancel, and pi will be in the numerator. Pi radians equals 180 degrees, so that's basically where this conversion comes from. So when we multiply, we would get 12 pi over 18. The zeros divide out and the degrees divide out. And they're both divisible by 6, so that would be 2 pi over 3 radians. 7 pi over 6, we can multiply. We want an answer in degrees, so we'll put the degrees in the numerator. And the pi's divide out. 180 and 6 give you 30. So the answer would be 210 degrees. The next one, be careful. This is a degree mark, not a zero. Oops. This is a degree mark. So you're going to multiply by pi over 180. The degrees will cancel, and you'll have 2 pi times pi over 180, which the 2 and the 180 divide, and the 2 pi's give you pi squared. So you have pi squared over 90. And that's in radians, so no degree mark with that. The last one in this section, 1/2. 1/2 is in radians, not degrees. There's no degree mark. So it's 1/2. You want your answer in degrees, so you have 180 in the numerator. So this would be 180 over 2 pi degrees. It's kind of nice to put in parentheses. The whole thing is degrees. So you have 90 over pi degrees. And you can leave it in terms of pi. Don't do like 90 divided by 3.14 or anything like that. So that's from a previous lesson yesterday. And then the last couple that we have, evaluate the trig function without a calculator. And the tip is to draw axes and use reference angles. That'll work on most of these, but not all of them. So you draw axes, you graph the angle of 315, which is this angle, and you draw a vertical line to make a triangle. It's always vertical. Reference angle is created with the x-axis, the terminal side. So we're looking for this angle in here. So if this angle would complete a full circle, so the whole circle is 360 degrees, we just used up 315, so that means we have 45 degrees left. So this is a 45, 45, 90 triangle. And then you have to fill in the side lengths, 45, 45, 90. So that would be a 1 up here, a square root of 2 for a hypotenuse, and a -1 on this side. And again, it's negative because you're drawing a line down going below the axis. So these are negative y values compared to positive y values above the axis. And then sine would be opposite over hypotenuse. SOHCAHTOA, opposite over hypotenuse. And then you'd rationalize the denominator to have square root of 2 over 2. And how about you try the next two? On the next three, we have a problem. The problem is these are called quadrantal angles. Quadrantal angles are angles that do not lie in a quadrant, they're on an axis. So 90 degrees is this angle. So to answer these, we can't really draw a triangle because we have to draw a vertical side, and we already have a vertical side, so we don't really have a triangle. So we need this ordered pair. The ordered pair here, the radius is 1 on a unit circle, so it would be 0, 1. And the y-coordinate gives us the sine of the angle. So sine of 90 would be 1. That also means if you were asked cosine of 90 degrees, cosine of 90 corresponds to the x-coordinate, so that would equal 0. But you aren't really asked for that. Cosine of 0 degrees is right here, 0 degrees. And you need this ordered pair, which is 1, 0. And cosine corresponds to the x-coordinate. So we would have cosine of 0 is 1, which obviously is the same thing the calculator gives us. Cosine 0 is 1. And tangent of pi radians, you could convert this, if you're not sure what it is, multiply by 180 over pi. The pi's divide out, so this is the same as tangent of 180. And the coordinates for this are -1, 0. And tangent corresponds to y over x. The y-coordinate divided by the x-coordinate.
0.
So it would be 0. 0 over -1. So the answer is 0. Okay, the last three are all in radians. So you could change them to degrees, Or you could try to work with fractions. I like to try to work with fractions. 5 pi over 6. If you think of what quadrant 5 pi over 6 would be, if you know that pi is a half of a circle, that much is pi. 5 pi over 6 is going to be less than a half circle. So less than a half circle would put you in this quadrant. And if you notice the 6, if we converted it, it would be 180 divided by 6, which is going to give you a 30. Anytime you have a 6 in the denominator, a 6 is going to give you a reference angle of a 30. So if you see 5 pi over 6, you can put it in the second quadrant. It's 5/6. Right? 5/6 is less than 1. So 5/6 pi is less than 1 pi. So you're in the second quadrant with the reference angle of 30. So that would look like this. Second quadrant, reference angle of 30, or pi over 6. 1, 2, negative square root of 3. Sine is opposite over hypotenuse. So the answer would be 1/2, without having to convert to degrees. 3 pi over 2 is the same as, you can think of it as being between, halfway between pi and 2 pi. Half of a circle is pi. A whole circle is 2 pi. So that would put us down here. So this is a quadrantal angle. It's on an axis. So we can't use the triangle method that we were doing. So we need the ordered pair. Ordered pair would be 0, -1. And secant is the reciprocal of which function? Cosine. So cosine corresponds to the x, sine corresponds to the y. So cosine of 0, what is the reciprocal of 0? You had 0 over a number. What's the reciprocal of that? You'd have 1 over 0. 1 over 0 would be undefined. Or you could write it like that. So what that means is, if you had 1 divided by cosine of 270, you're going to get division by 0, which is undefined. So it's no solution. Last one, 9 pi over 4. If you think about fractions, this is a little bigger. It's 1/4 bigger than 8 pi over 4. So 8 pi over 4 is less than 9 pi over 4. 8 pi over 4 is 2 pi. 2 pi is a full circle. So if you go this much, that's 2 pi. So you're going to go that much plus 1/4 of a pi. 1/4 of a pi would put you in the first quadrant. And if you see the 4, then that means you're going to have a 45-degree reference triangle. Just like when we saw a 6, that gave us a 30-degree reference triangle. If you see a 3 in the denominator, that would be a 60-degree reference triangle. So you would have a 9 pi over 4 is this rotation. You would go, this angle is once around plus a little bit more. So it's 45 degrees, you have 1, -1, square root 2. Tangent is 1 over, or sorry, that's a positive 1, 1 over 1. So tangent of 9 pi over 4 would be 1.